this example, we're going to find D for an infinite sheet of charge with surface charge density sigma. Let's start by drawing a diagram. Here you can see that I've drawn 2 points of view, the side view and the top view. For the side view, you can see the electric field going out perpendicular to this infinite sheet, and for the top view you can see the uniform distribution of charge on the infinite sheet. Think about what sort of Gaussian surface might work here. I'm going to use a cylinder because it works well. Pay attention to these dimensions that I've given it, especially the radius. I've called that A. You can give it any letter you want. In this diagram, I've superimposed the infinite sheet with this cylinder. That helps us out because you can easily see what Q enclosed is now, because it's just the area multiplied by the surface charge density. That's the charge enclosed by this Gaussian surface. Let's go back to the equation for Gauss's law. Here you can see the equation for Gauss's law. This is different from the sphere example we had done because the cylinder has 3 surfaces. So I've split up this integral into 3 parts. There's the top cap, the bottom cap, and the wall. And we have these respective ds elements for each of those parts. Let's find these elements now. Because I've picked my Gaussian surface to be a cylinder, I'm going to use cylindrical coordinates. Here's just a diagram showing the unit vectors and cylindrical coordinates. The approach to solving the question is very similar to that of the point charge, where we had split up the sphere into tiny portions. I'm going to do the exact same thing with the cylinder. I'm going to slice it and keep slicing it into tinier and tinier portions until I can easily see what the ds elements are. Here I have my first slice. You can see it looks like a bit of Swiss cheese almost, and I have a little bit going in the z direction, a little bit in the rho, and this is just an arc length. If you remember your basic math from high school, to find the arc length you would multiply the radius and the angle that was made by that arc. So that's the same idea over here, except we're using that idea of a little bit. So all the way around the cylinder you would have phi. Over here in this little chunk you have d phi, and what comes out from the origin outwards is you have rho. So this arc length must be rho d phi. I've just taken that chunk and blown it up, and when you cut into it many times, you get this prism. These are the dimensions, d rho, dz, and rho d phi, and these are the respective unit vectors. Now I can think about the ds elements for each of those integrals. So these are the top caps that I've talked about earlier, and this is the wall of the cylinder, the ds element for the wall of the cylinder. Let's plug these in to the expressions that we have talked about before, where we had split up that integral. So here's our previous expression. So these aren't equal to signs, these are plus signs over here. Please take note of that, my apologies. All I've done is just plugged in the values that I've gotten before. So I know d goes in the a hat z direction, and if you're talking about the bottom of the cylinder, then it goes in the negative a hat z direction. Here we have the wall of the cylinder. So this integral corresponds to the the S3 expression. This corresponds to the S2 expression, and this one over here corresponds to the S1 expression. There's something awesome about this integral over here in that you can see right away that this dot product goes to 0. So we can completely ignore this integral. And it makes sense intuitively too, because all the electric field goes out through the caps of this cylinder and not the walls. So after you solve those integrals, I've talked about the dot product going to 0, you get these 2 bits, and you know that the Q enclosed is pi squared times sigma, We'd found that earlier. Now you just solve for d, so you know the magnitude is sigma over 2. And this over here, this final answer makes sense intuitively because at the bottom of that infinite sheet of charge, where you're below the z-axis, you have d going in the negative a hat z direction, and for the top, you have d going in the a hat z direction. That marks the end of this video. Thank you very much.